Benchmarking sports AI, measuring what current pose estimation models can and cannot do under athletic motion. The generalization of pose estimation models to sports contexts has been assumed rather than measured. CalTennis provides an empirical basis for the claim that standard benchmarks do not predict performance on athletic motion, and begins to isolate which performance dimensions are specifically degraded, a prerequisite for targeted methodological progress. CalTennis reveals a dissociation, relative joint angle estimation, where current models perform reasonably, versus absolute depth and foot contact timing, which fail systematically. This pattern is consistent with the hypothesis that models trained on quasi-static general motion learn appearance-based shortcuts for joint configuration that do not transfer to the temporal and depth demands of fast athletic action. Whether sport-specific training data alone would close this gap, or whether it reflects a structural limitation requiring architectural change, is not resolvable from benchmark performance alone. Depth estimation and ground contact timing are mechanically coupled in many athletic tasks. Contact forces depend on both. A model that fails both simultaneously is likely to produce biomechanically implausible estimates precisely during the high-load events most relevant to injury risk. The benchmark's contribution is making this failure mode testable and reproducible, which is the precondition for eventually resolving it.